Everyone, my name is Bhavish Lohar and I welcome you on my YouTube channel Quest Achiever. So now we are continuing with the series that is digital electronics, and we completed till K-map, and now we are continuing with the combinational circuit. So in combinational circuit many circuits are there like comparator, adder, subtractor, and mux, demux, and encoder. Many more circuits are there, so we will study one by one each combinational circuit. And first we will see basically what do you mean by combinational circuit. A combinational circuit is what basically means it is the circuit which basically doesn't have any feedback, means there is no relation between the output and input. Okay, it is like open system. Okay, means it depends only on the present input, not on the previous. Okay, so we have two kind of circuits like combinational circuit and sequential circuit. We will study sequential circuit also. So basically in sequential circuit we have present input and previous input also there, but in combinational circuit we have only the present input. There is no feedback, there is no relationship between the basically output and input, and basically there is a only thing is that we are providing input and we are getting the output. So first we will do basically which kind of circuit we will studying. Basically we are studying basically one comparator. We are studying basically comparator. We will study first circuit, that is comparator circuit. Okay, we will study what? The comparator circuit. Okay, in that many things are there. We will see one by one. Many more circuits are there, so we will complete one by one. Okay, so in comparator circuit basically we will compare two numbers. So suppose I am taking one number, that is A, okay, and another number, that is B. Each A number is basically of 1 bit and B also is of 1 bit only. Suppose these two inputs are applying to one circuit, that is a comparator circuit. That is a comparator circuit. In this, out of this basically we will get basically output. Okay, we will get basically three output in this. Suppose first output will basically suppose X, this is Y, and this is Z. Okay, comparator means comparing, means A is greater than B, A is less than B, or A equal to, means suppose this will give me a basically result of A greater than B, X will give me a result of A less than B, and Z will give me a both are equal. Understood? So comparator, we don't know na, basically A is greater or B is greater or both are equal, so we don't know. So comparator means basically the three result will be there, greater than, lesser than, or equal to. Understood? So we will see, this is our basic thing. Now how many inputs are there? Two inputs are there. We are comparing two number. In the comparator circuit we are basically comparing two number, that is A and B. Each is of 1 bit only, 1 bit number. Okay, this A and B is of 1 bit number. Understood? 1 bit number. Okay, so basically first we do for 1 bit, then we go for the 2 bit, then and so on, 4, 3, 4, 5, 6, and so on. Okay, many things are there. So we will start with the first bit, that is 1 bit only. Okay, then we will take little bit tougher, that is 2 bit, and many more circuits you can build. Okay, so n bit means n bit comparator. Okay, now next is basically, this is your first step to identify basically how many number of inputs are there, and this is outputs. Okay, this is whenever you do a combinational circuit or any designing are there in the combinational circuit, we basically what we do, we basically first see the inputs, how many inputs are applying to the comparator circuit and how many outputs are there. So first step is basically to identify the number of inputs and the number of outputs. Second step is what? You have to make a truth table. You have to make a truth table. Two inputs are there, then you will get a 4 possibility. Then you will get the 4 possibility. What are the 4 possibility? Basically 4 possibility will be there basically 0, 0, 1, 1, 0, 1, 0. Whenever two number will be there, then you will get in digital electronics is basically 4 possibility only. So that is, you have X, you have Y output, and this is your Z. Clear? So in this both are same, then this will get high. Okay, because Z is what? A is equals to B. Z is what? A is equals to B, right? So both are equal, this is also both are equal, so this will be high. The rest in these two case will be 0 because both are not equal, right? In this case basically this will get be 0 because 0 0 is not. X is what? A greater than b. 0 is greater than 1? No. 1 is greater than? Yes. This will be 0. Okay. In same this is 0. This is x. 0 is greater than 1? No. 1 is greater because in y what we want, b term is must be greater than a. So here it will be 1. Here basically 1 is greater than. So 0 0. In short, basically what is there? What thing is there in? Basically x is giving me that the result where x a is greater. So a is greater is that it is equal part, it is lesser part, this is greater than. See, this is 1, this is 0. So which one is greater? This one is greater, right? 1 is greater than b. 1 is greater than b. 1 is greater than b means this bit will become high. This is less than b, then means b is greater, means one bit is high. When both are equal, then this will high, this will high. Understood? Now the second step is what? Is that truth table, making the truth table from the given condition. Okay, now what we will do basically, we will form the equation. What we will do basically, we will form basically equation. We will form the equation. Now suppose for how to make equation, we already studied the K-map. Now we required equation for the A. We required equation for A. So how we will do basically, A will provide by this, two inputs are there, so the combination 0 1, we already studied the K-map 0 1. Okay, we will make the K-map. X will give the result when 0 0 0 1 1 0 and 1 1. Okay, so when we are getting value of 1, so this is 0, this is also 0. See, just see in the basically in this. Okay, so 0 0 will give me a 0 only. 0 1 is what? 0 1 is what? 0. 1 0 is 1. 1 0 is 1 na? 1 1 is basically 0. Clear? I think this much is clear, right? Now same we have to do for y also. Same do for y also. So you will basically, we will write basically afterwards only the final equation we will write together only. So now I am not writing this. Okay, I am directly putting the values. So 0 1 0 0. Similarly for z also we can write a b. You have to make a K-map just to minimize the equation. Understood? So this three equation we will get, one for x, one for y and one for z. So what will be the value of this? So this is what? A and this is b bar. So a b bar. Y what? Basically this is a bar b, a bar b, and z with what? This is what? A bar b bar, and one is basically a and b. We already studied the basically K-map, so just watch if you don't know the K-map. Okay, my lectures that I already made video on basically on K-map. Okay, how to do. So you can write this is what? This is the equation for x nor. You already know, right? So what we did basically, first step is basically what? First step is to identify the number of inputs. That is the this case. In this case basically what we did basically finding the number of inputs and output. The comparator, what will we do? Comparator basically compare the values. It will tell you that this is the greater, this is the lesser, or this is the equal. The three condition will be there, right? Okay, and basically after that we made a truth table. That is the truth table. This is what? Truth table. Which table is that? This is truth table. Okay, and after that basically we did that is equation to minimize the expression. Okay, how the equation is come, and I already told you how to write it. 0 0 का value यहाँ से लिखना है, and same thing, that is what we write in the truth table, same thing you need to list it down in the K-map. Okay, 2 bit, then 4 block will be there. Okay, 2 raised to 2 is 4 only. Now we will basically do the minimization, but in this basically we don't need to minimize it because it is already in the minimized form only. Okay, this is your fourth step. See, we did basically for third step, and now the fourth step is what? Minimization, but it is already in the minimized form, so no need to minimize. Okay, further now basically what we do, we will make a hardware implementation of this. Hardware implementation means how basically what kind of basic circuits will be required implementation. Okay, Like suppose A and B are the inputs, so we will take this A and B are the inputs. NOT means this is your NOT gate. Okay, so A bar will come from this side, this is A bar, and this is B bar will come. Okay, now for getting X value we require basically A into B bar. A into B bar means this is B bar and this is your A bar. Okay, you can do directly also. Okay, no need to this. And for Y, after this output you will get basically what? X. And Y is basically what? A bar B. A bar B. So this is what you will get basically Y. And for Z basically you will get, you need required basically what? You required basically X NOR. X NOR, there will be a bubble. Okay, X NOR of what? A and X NOR of B. Okay, so this is your circuit implementation. What we required basically, how many circuits we required? This is NOT gate, 2 NOT gates we required because for bar, and one AND gate, and this is for this. So this will give me a greater than B, X, Y will give me a basically A less than B, and this will give me a basically a Z equal to A equal to B. So this, I think we did this much. Okay, this is your last step. Okay, in this case basically minimization we won't required. Okay, so basically we won't did because it is already in the minimized form only. X is equals to A bar B, X is equals to A bar B, Y is equals to this. Okay, so I think this much is clear, and we will study in the next class basically 2-bit comparator. Okay, this is basically 1-bit comparator we studied. In next class we will do basically a 2-bit comparator. Okay, so till then, thank you so much.